Hey there everyone, let's take a look at our review for chapter 5. We're going to start off factoring. I've got x to the 6th plus 7x to the 5th. 1 and 7 don't have anything in common, but they both have a 5. And as a matter of fact, they can both afford to give up, let's see here, 5 factors of 5. So I'm going to pull out 5 factors of 5. 6 minus 5 is 1. And no x remains in the second term, so that's our factoring. We're going to factor here, and for this second problem, we've got 4, 4, and 28, so I'm going to pull 4 out of everything, so it'll be 4 times the quantity, x to the 6th, plus x minus 7. And that x to the 6th means I'm done. I don't know what to do with that. So we'll just leave it. Number 3 here, let's factor this. I'm going to start by pulling out x cubed, and then we'll have, let's see here, 11x cubed minus 10x plus 7. And 11, 7, 10 cubed, linear, no x. We're done here as well. There's just that one factor we can pull out. Great. Here's another factoring problem. X to the 4th times x plus 9 plus 7 times x plus 9. Both of these have that factor of x plus 9. So we're going to factor that out, and we'll be left with x to the 4th plus 7. So we're done there. Likewise, for this next problem, 2a to the 4th times 8a minus 5 plus 3 times 8a minus 5, that factor of 8a minus 5 is repeated. And we'll have 2a to the 4th plus 3 remaining. And for both of these, something to the 4th, a positive, and then a prime number, oh, there's nothing we can factor there. There's nothing there for us. So we're just going to go on to number 6 here. We've got w squared plus 10w plus 21. And what we're going to do here is we're going to use our pull apart factoring, and we're going to look at factors of 21. Now, we've got 1 and 21, but they add to 22. We've got 3 and 7, and they add to 10. That is a match for this middle term right here. So we're going to use 3 and 7 to pull apart this trinomial. We have w here plus 3. Then we'll have w plus 7. And that's our factorization. All right, next set of exercises. We're going to factor this polynomial p squared minus 14p plus 49. If the polynomial is prime, so state. It's not prime. As a matter of fact, right here, 49, that's screaming at me. 7 squared is 49, and that matches what we've got going on right here in the middle. That negative 14. That negative 14 is 2 times a negative 7. So this whole thing is a perfect square. It's p minus 7 quantity squared. Okay. 8. Not a perfect square here, 48. So we're going to use pull apart factoring. R squared plus 16rd plus 48d squared. We're going to take the factors of 48, and we're going to look at those. 2 plus 24, no. 3 plus 16, no. 4 plus 12, yes, that's 16. So we'll have r squared plus, whoops, not r squared. We'll have r plus 4d times the quantity r plus 12d. That's our factorization. And then number 9 here, 5x squared minus x minus 18. This 5 doesn't factor out. This is going to mean AC method. So I'm going to take 5 and I'm going to multiply it by a negative 18. That's going to be a negative 90. And I need two factors of negative 90 to add up to negative 1. Well, I'm pretty lucky because I don't have to go through all of these. I'm going to take a guess that it's going to be negative 10 plus 9. Yup, that's a negative 1. So then I'm going to come up here. I'm going to keep working on this. I'm going to take 5x squared minus x minus 18, and I'm going to break apart that minus x in the middle there. I'm going to use this to break it apart. I'm going to break that negative 1 into minus 10x. I'm going to break this into plus 9x. Okay. So then, factoring by grouping gets us 5x times x minus 2 plus 9 times x minus 2. And as we've factored by grouping before, we've got this repeated, x minus 2. So that'll be x minus 2 times 5x plus 9. Great. In this example, the middle term has already been split. So for number 10, we're just going to factor this as r times r plus 4. And then I'm going to factor out a 9. We'll have r plus 4. So we'll get r plus 9 times r plus 4. Easy enough. We're going to do the same thing with number 11. I'm going to factor an a out of the front pair. So we'll get a times a minus 4, and I'm going to factor a negative 1 out of the second pair so that minus a plus 4 becomes a minus 4. The signs change, and this gives us a minus 4 times a minus 1. Okay. Lastly, right here, we've got b squared minus 8b plus 16. Aha! That's a negative 4 squared, and negative 8 is equal to 2 times negative 4, so this is 2 times negative 4 right there. So this whole thing is going to factor into b minus 4 quantity squared. And I knew that by seeing that 16 as negative 4 squared. Determine whether the expression is a difference of squares. R squared minus 3 squared. Oops. Determine whether the expression is a difference of squares. R squared minus 3 squared, yeah. A squared minus 15 is not a perfect square. No. So let's factor a difference of squares right here. This is v squared minus 8 squared. This is v minus 8 times v plus 8. That is how a difference of squares factors. Here's another difference of squares to factor. 4b squared minus 81g squared. Well, the square root of 4b squared is 2b, and the square root of 81g squared is minus 9g. Great. Then we'll have 2b plus 9g. There we go. And remember, the opposite signs are going to cancel out. Cool. My goodness, how are we going to factor this? B cubed minus 25b squared minus 4b plus 100. Man, it's not like it's a perfect square or anything. Wait a minute, there's 1, 2, 3, 4 terms. Let's do a little factoring by grouping here. We'll get b squared times b minus 25. And I think I can make the back half of this. I think I can make this match b minus 25 by factoring out a negative 4. Then we'd get b minus 25. Yeah, great. So this whole thing is equal to, I'm going to write b minus 25, right, because they both have that in common. And then there's the b squared minus 4. Okay, so b squared minus 4. And, ooh, look, this factors as well. That's a difference of squares like before. This is going to be, let's see, b plus 2 times b minus 2. And this is still b minus 25. So that's our completed factorization. Now let's take a look at number 18. 12u cubed plus 4u squared minus 96u. I'm going to start by factoring a u out of everything. We'll have 12u squared plus 4u minus 96. These all have a 4 in common, so 4u times 3u squared plus u minus, let's see here, 4 goes into 96, 14 times, no, 24 times, yeah, 24 times, right? Mm-hmm, 24 times. Then we have to do AC method with AC equal to 3 times a negative 24. That's going to be equal to a negative, let's see here, 82? No, 72. Negative 2 plus 36, no. Negative 4 plus 18, no. Negative 8 plus 9, yes. Cool. So then this is equal to 4u times 3u squared minus 8u plus 9u minus 24. This is equal to 4u times, will be u, 3u minus 8 plus 3, 3u minus 8. This is 4u times u plus 3 times 3u minus 8. Whew. Took us a little bit, but we got there. Let's see what's on the next page. So we have solved using the principle of zero products. Each one of these three, 1, 2, 3, we can set them equal to 0 individually. T equals 0. We don't need to include the 5, but I think it makes it read easier when we do. 4t minus 5 equals 0. 4t equals 5. T is equal to 5 over 4. And then lastly, we've got 5t minus 1 is equal to 0. 5t is equal to 1. T is equal to 1 divided by 5. So t is equal to 0, 1/5, and 5/4 in ascending order. Great. So now to solve this problem, we're going to have to factor it. b squared minus 11b plus 30 is equal to 0. Let's factor. 5 times 6 is 30, and 5 plus 6 is 11, so that means negative 5, negative 6. That's what we're looking for. So b squared, b minus 5 times b minus 6 is equal to 0. Now, 5 minus 5 is 0, and 6 minus 6 is 0. So b is equal to 5 or 6. All right. And that's it. And that does it for the Chapter 5 portion of the review.